Okay, so section 6.3 is on integration and antiderivatives. All right, we've already talked about antiderivatives a long time ago. Integration is just antiderivatives. But there's something called definite integration and indefinite integration. Okay, so a definite integral is going to be when you have numbers that you're going to plug in. And indefinite is where we have some kind of constant that we don't know. Okay, so suppose you want to know the velocity of an object at a certain time, but you want to know its position. Or suppose you know the velocity, you want to know its position. Or maybe you know the rate of change of something, but you want to know the actual population. So you need to do the opposite of deriving. So you have the derivative already, you need to find the original function. This is called antiderivatives. Okay, so number one, I have 1 over x cubed dx. So when you see this integration sign, that's like the elongated s, that means take the antiderivative. So you guys know your power rule. This is the same as x to the negative 3 dx. So you're thinking to yourself, how do I get the derivative of something to be x to the negative 3? So what would the antiderivative of x to the negative 3 be? X to the negative what? What'd you say? 2? Yep. Okay, now what number do you need out front when you take the derivative? You would need a negative 1/2, right? All right. And then we can have any constant on the end. Because if I had negative 1/2 x to the negative 2 plus 5, when I take the derivative, I get x to the negative 3. All right, I could have plus 5, plus pi, plus 7/2. You know, I could have any number on the end. So you always need to do a plus c. So that's when we have an indefinite integral. You need plus c. That's something that I forgot when I was in calculus on one of my tests on every single problem. So please don't do that. Yeah, it was. All right, number 2. So I have the square root of x dx. Yes.
How do you write like the big thing? Like, how do you write like the, you know how some of the other ones is like f prime?
Yeah, like the derivative was like y prime or f prime, or you could write dy over dx. The antiderivative is going to use this integration sign. Okay. You might also see if they have f of x equals something, they might say find capital F of x. That would be the antiderivative. So you already have little f, you need to find capital F. That would be the antiderivative. All right, so next one. So I have the square root of x, so that's x to the 1/2 dx. So when I take the antiderivative, it's x to the 3 over 2, right? With what out front? 2/3. So how did we find the derivative? So if I started with this one, how do you find the derivative, Catherine? You subtract 1 from the power, right? So what if I was going the opposite way, you would have to add 1, right? And then once you get that power, I always just use the reciprocal for the number out front. Mm-hmm. Yep. All right, next step. So I have 2 sine of x dx. So you can actually pull the 2 out front. We talked about that. It's just like our infinite sum. So if I have the antiderivative of sine of x, so what do I take the derivative of in order to get sine? Negative cosine, right? So it's 2 times negative cosine of x plus c. So it's negative 2 cosine of x plus c. Now a lot of people ask, do you need to put the c in parentheses? You can, but then 2c is still a constant. So we usually just tack it on to the end. Right? It's still a constant. Okay. So the power rule. So this is what Victoria was just asking. Isn't there a formula? There is a formula. So if f of x equals x at the end, then capital F of x is the antiderivative. So we use the integration sign of little f of x. And it ends up being x to the n plus 1 with a 1 over n plus 1 out front. So you can do over n plus 1 if you want, plus c. So you add 1 to the power and you divide by that new power. In other words, you take the reciprocal of the new power if it's a fraction. Okay, notice we made the stipulation that n could not be negative 1. In other words, we don't know how to find the antiderivative of 1 over x at this point. So if I had the antiderivative of 1 over x, That's x to the negative 1 dx. Think about adding 1 to that power. You get x to the 0. So really, what is the thing that you take the derivative of to get 1 over x? You guys know that already. Ln x, right? Natural log of x. So in this case, it's actually natural log of the absolute value of x, because x can never be negative. So we'll talk about that later on. All right, so number 1, I have f prime of x equals 1 minus 6x, and f of 0 equals 8. So if f prime of x is 1 minus 6x, f of x, so it's antiderivative, is x minus, what's the next thing? 3x squared plus c. So Jenny said, shouldn't it be capital F? Kind of, but this was f prime of x originally, not little f of x.
Oh, so that's the original.
Yeah.
How do you get 3 in the front?
Think about taking the derivative of this term here. The 2 would be multiplied by the 3, right? So you get negative 6x. Yeah, so basically what you're doing, if I wrote out all the steps here, it would be 6 out front, and if I was just taking the antiderivative of x, it'd be x squared with a 1/2 out front. So 6 times 1/2 x squared plus c. So it's x minus 3x squared plus c equals f of x. Okay, but we were given additional information. We were given that f of 0 is 8. So that allows you to solve for the c value. Okay. So I get so 0 is x, so I have 0 minus 3 times 0 squared plus c is equal to f of 0, which is 8. The c is called the constant of integration. So when we have these differential equations, it allows you to solve for the constant of integration. All right, so c is equal to 8. That doesn't always happen. It's not always nice like that. All right, so your original function then was f of x equals x minus 3x squared plus 8. And if you're Jenny, then you write that in order, negative 3x squared plus x plus 8. Do the rest of you guys do that too? You don't like it to be in that order. All right, next one. So f prime of x is x to the 3 over 2, so that means f of x is x to the, add 1 to the power, 5 over 2. No. Yeah, 5 over 2. Not crazy, am I? And then 2/5 out front. Plus c. So f of 1 is 2, so I get 2 equals 2/5, 1 to the 5 over 2 plus c. So that ends up being 1 times 2/5, so 2/5. So I get 2 equals 2/5 plus c. So I have 2 minus 2 over 5 equals c. So 2 is 10/5 minus 2/5. Yep, so 8/5. So your final function then is f of x equals, we know the c value, so it's 2/5 x to the 5 over 2 plus 8/5. So that's the function that satisfies that point, and it has that derivative. All right, so here's one that has multiple ones. I think you have one like this on your big final review packet. All right, f double prime of x is 20x cubed plus 12x squared plus 4. So f prime of x is, take the antiderivative, so I'd have x to the 4th, so I need a 5 out front to make 20. Do you guys see how I'm doing that? Okay. The next one's going to be x cubed. I add 1 to the power. What do I need out front to make the 12? 4. Plus 4x plus some constant. Okay, now this one's a little tricky. A lot of times they'll give you f prime of something equals a number, so then you can find that c value. But in this case, I just gave you 2 f values. Okay, so I need to find f of x. So I'd get x to the 5th with a 1 out front, right? Plus x to the 4th with a 1 in front. Plus x squared with a 2. Plus cx And then we need another constant. So when we need another constant, I write plus d. You could also do c sub 1, c sub 2, if you want to use subscripts. So we were given that f of 0 is 8. So I get 8 equals 0 to the 5th plus 0 to the 4th plus 2 times 0 squared plus c times 0 plus d. You could just write 8 equals d, right? Tornado alarms. Yes? Why do we need what? Because now we integrate it again. So I was started at f double prime. So I went to f prime, and then I went to f. So each one means a constant. All right, so then I have d is equal to 8. Now if I had f of 1, so f of 1 is 5. So I get 5. I'd have 1 to the 5th plus 1 to the 4th plus 2 times 1 plus c times 1, so c plus d. And d is 8. So I get 1 plus 1 plus 2. So 4 plus c plus 8 equals 5. So what do I get? Negative 7. Is that right? C equals negative 7. So your final function, your f of x, was f of x equals x to the 5th plus x to the 4th plus 2x squared plus c was negative 7, so I guess minus. So minus 7x plus 8. And that was the function. And you can check. You could take the derivative. You get, or we'll take the derivative twice. You get that f double prime. Or you could plug in those 2 points and you'd get those values for f of 0 and f of 1.
How come you see x and d?
Because on the first one I had f prime, so I had some constant. So let's say we knew the constant was negative 7, which it ends up being. Now when you take the antiderivative of that, you need negative 7x here plus some other constant, because we don't know what that next constant was. So that's why you need C and D. All right, so A, a car is traveling at 73 feet per second when the brakes are fully applied, producing a constant deceleration of 22 feet per second squared. So that's your deceleration. So A, it's negative. What is the distance traveled before the car comes to a stop? Okay, this is a tricky one. So start with, this is your second derivative of the position function. So when we're talking about how far it traveled, that's a distance, that's a position. Okay, so A is negative 22 feet per second squared. So my velocity is the antiderivative of that. So it'd be negative 22, we'll use t, because we usually use t in these, plus some constant. At time 0, the velocity is 73 feet per second, right? So at the beginning of the braking, you were already traveling 73 feet per second. So if I plug in 0, my velocity should be 73. So that means c is 73. That always happens on these. C is your initial velocity in these. All right, now your position, s, is the antiderivative of your velocity. So let me write, so c equals 73, so my velocity, v of t, is negative 22t plus 73. Okay, so my position function is going to be the antiderivative of my velocity. So I'm going to have negative 11t squared plus 73t plus a new constant. So since I already found c, I don't want to write c because it's not 73. It's another constant. So we use d. Why is it d?
No, why is it 72t?
Because we're taking the antiderivative of this part.
Oh.
So you had 73, so it'd be 72t. All right, we want to know the distance that it traveled before the car came to a stop. So what I always do on these car ones, or these, stopping ones, is I make the beginning position 0. Because I'm trying to find the distance that it took to stop. So d should be 0. Do you guys understand that? I mean, you could call it 20 feet or whatever, then the next one's going to be 20 more. It doesn't really matter what d is, but I make d equal to 0. So my position is really s of t equals negative 11 t squared plus 73t. Okay, so we want to know how long it took. Well, we want to know the distance that it took to stop. But in order to find that, we need to know how long it took to stop, right? Yes?
Why did you make the 0?
So if you have a car, I mean, your car could start anywhere. You could make this 100 miles for the starting position. Huh?
What is the d then?
D is your initial position.
Oh,
Does that make sense? If you plug in 0 for the t's here?
so it's not like the y or something, it's 0.
Yeah. Just like the last one was initial velocity. C was initial velocity. All right, so I want to know how long it takes to stop, and then I'm going to find the distance it traveled. So how do I find how long it takes to stop? 0 for s? Not quite. Because this is going to be a new position. Position equals, we don't know. It's not like one where you're like firing it into the air and the height is 0. Velocity equals 0. We need to know when the velocity is equal to 0. So go back to your velocity equation. So I get 0 equals negative 22t plus 73 and solve for t. So it ended up being 73 over 22. I need my calculator. It's not very nice. All right, now what? We want to know how far it traveled, right? So your time was 73 over 22 seconds. You're going to plug that into position now. So you're going to find the position after 73 over 22 seconds. So I have negative 11 times 73 over 22 squared plus 73 times 73 over 22. Did we get it? 101 point what?
121.
Speak up. 121 point.
114.
114 meters, right? Feet. Okay, you guys get that? All right. I know that's a hard one, so go back and definitely look at that and think about the steps that we did to get it. Those are hard ones. All right, let's kind of skip the next one. So let's look at these integration ones. You can try number 5 if you want, but same kind of thing. All right, so number 1, I have x plus 1 all over the square root of x. All the time I have students that look at this problem and have no idea what to do. These are constantly on the multiple choice questions. Okay, this is an easy problem. It should take you like a minute to do it. So what's an idea? Like, what do you think we should do? Yeah, so well, no, we can't do quotient rule backwards. Yeah, this is x to the negative 1/2, right? Since on the bottom. So what you're really saying is that you can multiply x to the negative 1/2 n. In other words, what I'm saying is you can divide by square root of x into both pieces. So it'd be x over the square root of x plus 1 over the square root of x dx. That's the opposite of getting common denominators and combining. We're just taking those common denominator and we're separating it out. All right, so this was x to the first power, and the bottom was x to the 1/2 power, so 1 minus 1/2 is 1/2. So I'm going to have the square root of x, so I'm going to write it as x to the 1/2, plus x to the negative 1/2, like Jenny was saying. All right, now you guys can take the antiderivative. So take the antiderivative. That's what we get. So it's x to the first over x to the 1/2. So it'd be x to the 1 minus 1/2. You subtract your powers. So x to the 1/2. You can also think of it if you have x on top and square root of x on the bottom. X is square root of x times square root of x. So they cancel. So you can think of it that way too. All right, so what did you guys get? 2/3 x to the, minus 2x to the 1/2. Perfect. Plus c. Got it. All right, so next one's kind of similar, so you're just going to break up your integral.
Why is it minus?
Oh, is it? Yeah, it should be plus, yeah. Yep, you're right. Okay, so next one. So bring the x squared into both pieces in the second part, and think of the 5. Like, people don't like that as well. X, what is it? X to the 5th over 5. Think of it as 1/5 x to the 5th. So the number is 1/5 out front. So I have 1/5 x to the 5th minus 4x squared plus 3x dx.
Would it be minus 3x?
Oh, yes, you're right. Man, I'm having trouble with my pluses and minuses today.
No bonus points?
Yeah, that's right. So who was it the first time? I know, and who got me on the last one? Rachel? Was that right? No, Rachel and Jenny. All right. I hear Dr. Vesper tries to get out of those bonus points in physics. My other class was saying that he'll be like, oh, I was going to catch that. I would have gotten that.
It's like, spelling mistakes don't count.
Oh, man. All right, so you can think of bringing the integration sign into each piece and integrating each piece separately. You can think of pulling the 1/5 out to the front if you want. I mean, can you guys do this? Do you guys understand this? So what I'm saying is, like, you can think of this as 1/5 the integral of x to the 5th dx minus 4 the integral of x squared dx minus 3 the integral of x dx. But you should really never write it that way because that's what you're thinking in your head, right? Sorry, I know you've just learned them, but okay, so what I'm doing is 1/5, and if I was just integrating x to the 5th, it would be 1/6 x to the 6th. Then minus 4, if I was just integrating the x squared, it'd be 1/3 x to the 3rd. Minus 3, so 1/2 x squared, plus c. So I get 1/30 x to the 6th minus 4/3 x to the 3rd minus 3/2 x squared plus c. Make sense? Okay. All right, how about the next one? So sine over cosine squared. We're going to learn some tricks for this next time, but any ideas on how to do this one? Not next time, but eventually we're going to learn. So think about like secant, things like that, cosecant, cotangent, tangent. What do we have? Okay, let's break it up. So let's think of it as sine over cosine times 1/cosine. And let's see if that gets us anywhere. So what's sine over cosine? Tangent. What's 1/cosine? Secant. Guys. So this is secant tangent. So what do I take the derivative of in order to get secant x tangent x? Secant. So it's secant x plus c. That's it.
Wait, what just happened?
What's the derivative of secant? Do I need to do my derivative drill again here?
Oh no.
When do we take those quizzes?
Whenever you want. Come find me. I have them on my desk. Dana was supposed to take it yesterday. Yes. So what's the derivative of secant?
Secant x.
I have no idea. Tangent x, secant x.
Yes, that's what we did. We did the antiderivative of secant x tangent x.
Okay.
Okay.
Got it.
All right, how about the next one? Ideas? FOIL. That's exactly right. 4x squared minus, it would be 12x, outer and inner, plus 9 dx. Now you can take the antiderivative. It would be x cubed. If I want a 4 out front, what do you need? Yeah, so you can put the 4 out front. You need a 1/3, so you really need 4/3 out front. Minus x squared, what do I need out front? 6 plus 9x plus c. So it's 4/3 x cubed minus 6x squared plus 9x plus c. Okay, so the main question, we're about to talk about definite integrals. So definite integrals are ones that have numbers at the top. So we talked about the shortcut method already. This is the shortcut method. You're going to be doing this every day for the rest of calculus. Just like you're doing, for derivatives. Once you learn derivatives, we did it every day for this first semester, right? Yeah. So we're going to do these all the time. All right, so your shortcut is that if you have the definite integral a to b of little f of x dx, capital F represents the antiderivative. So it's just going to be, I always write it as capital F of x going from a to b. So it's f of b minus f of a. So you're just plugging in those numbers into the antiderivative and taking the difference. Okay, so compute the following integrals then. So if I was going to take the antiderivative of 6x squared, what is the antiderivative of 6x squared? We're going to plug in 1, we're going to plug in 3. So I have 2 times 3 cubed minus 2 times 1 cubed. So I get 2 times 27 minus 2, 54 minus 2, 52. Okay, that's your answer. That's a times.
Wait, why do we have a minus?
That's what, yeah, that's the rule, yeah. Okay, next one, sine. Antiderivative, what do I take the what do I take the derivative of in order to get sine? Negative cosine. So I'm going from 0 to pi, so I plug in pi first, then subtract out, plugging in cosine of 0, or plugging in 0 next. So think about your unit circle. Cosine of pi, negative 1. So I have negative 1, plus, what's cosine of 0? 1. So negative 1, so 1 plus 1 is 2. So 2 is your answer. I know, and that's why I shouldn't have taught you those calculator tricks, because 2/3 of the test is non-calculator. So I would not just use FNNs, right?
The AP test?
Yeah.
You don't have to.
4 of the free
They didn't use
response.
calculator at all.
Yeah, that didn't start until pretty late. Yeah.
You're like sweating and
I love the little girl's voice that was really high and squeaky. I have to go. I have a scholarship. That was so funny.
You should all watch Stand and Deliver.
Sorry.
All right, guys. Let's go. Next one. How do we do it? 1/3 x cubed minus 4x. Why am I not doing a plus c on these? What if I did do a plus c? So what if I had done a plus c here? And then I plugged in 0 and then 2. And then I brought the 2 into each piece. So I did 1/3, 2 cubed, so 8, minus 4 times 2, plus c, so that was the first thing. And then I subtracted out the next thing when I plugged in 0. Yeah, you subtract them out anyway. They always cancel. So you can put plus c, but you really don't have to on these definite integrals. So if you have numbers on your integration sign, you don't have to put plus c. If you don't, it's called an indefinite integral, and you always need the plus c. Okay, so I get 8/3 minus 8. So it's 8/3 minus 24/3. So negative 16/3. So negative 16/3 is your answer. Okay, and the next thing is average value. Okay, so do you guys remember that the integral sign is basically an infinite sum? It's the limit as n goes to infinity of the sum of all the rectangles, right? That's what the integration sign really is. All right, so if I asked you to find the average height of all those different rectangles, what would you do to find the average height of an infinite number of rectangles? Yeah, so it's kind of weird. So what if I had 10 rectangles? How would I find the average height of those 10 rectangles? I would add up the rectangles and divide it. So I'd add up the height of the rectangles and then divide by 10, right? So I'd add up the height of the rectangles and divide by the number. You guys don't have to write any of this. I'm just sketching some ideas out. So the question is, how do I find the heights of the rectangles? So if I know the area of all of them, so if I have like the area of each rectangle, and I know how to add those together, that's the sum, right? Oh, yes. Amber says, well, then you could just divide by the width of the whole thing, the width of the base, which would be b minus a. We're getting there. So in other words, we're at the point where we're saying add up all the rectangles. Our infinite amount would be our integration sign. And then divide by the width. That would get your average height. So that's what we're going to do. We're going to add up all of the rectangles. So that's our area, our integration sign, and then divide by the width of the whole thing. Does that make sense? You'll see this all the time, average value. All right, so that's our formula. So it says if f is integrable on the average or on the closed interval a to b, then the average value of f on the interval is a to b f of x dx divided by b minus a. So we just write 1 minus b, or 1 over b minus a out front. Thanks.
I almost killed her.
I ran into someone. All right. So the average value, basically, you would add up all of the heights of the rectangles. So if you have an infinite number, there's no width there. So this is the adding up all the heights, right? And divide by the width of the space. All right, so the big thing on your multiple choice section is they have these scattered throughout. There are average value problems and there are average rate of change problems. These are not the same thing. Average rate of change is f of b minus f of a all over b minus a. It's related to the derivative, right? Average value uses the integral. So average value is the average f value. So it's the average y value. Okay, so both are on the AP test all of the time, so you need to know them. So find the average value of f of x equals 2 plus x minus x cubed on negative 1 to 5. So my average value is just going to be 1 over b minus a, so 5 minus a negative 1, from negative 1 to 5, 2 plus x minus x cubed dx. So it's 1/6. 2x plus x squared over 2 minus x to the 4th over 4. Notice how I'm just writing it over 2 over 4. Like, that's just like those are 1/2 out front and 1/4 out front. Same thing. I'll write it different ways. So. All right, and then we're going from negative 1 to 5. Okay, let's keep the 1/6 out front. Let's plug in 5 and then plug in 1. So Allie, you're going to plug in 5 for me. And who else has a calculator? Cam, you can plug in negative 1. Yep.
When you're putting in negative 1, do you still have the 1/6 out front and you subtract them?
Yeah. You could distribute the 1/6 to both of them if you want, but I usually just pull it out to the front. Okay, what'd you get when you plugged in 5?
Times 1/6.
Nope, just plug in 5.
Negative 133.75.
Mm-hmm. And what'd you get when you plugged in 1? I got it.
Are you plugging in a negative 1?
Yeah, negative 1. Yeah.
Negative 2.75.
I think it's negative 1.75.
Yeah, negative 2.75.
So if you're plugging in 1, you have 2 times negative 1, or negative 1, I guess. Negative 1 squared over 2, I bet that's what you messed up, minus negative 1 to the 4th over 4. So both of these end up being 1. So I'm going to have negative 2 plus 1/2 minus 1/4. So what's that? Negative 1.75. So I have minus a negative 1.75. Okay, so I have negative 133.75 minus a negative 1.75, so plus 1.75. And then divided by 6. So you get negative 22. So if you guys actually graph this out, you could look at the graph and you could kind of tell, yeah, that looks like about the average height. I mean, your heights are going to be kind of around 22, negative 22. Okay, so that might help. All right, are we at the end? Pretty much. Mean value theorem.